So, multi-step momentum questions. Okay. A force of 8 newtons acts on an object for 10 seconds. The mass of the object is 4 kilograms. Cool. Brady, what's A asking me to find? I gotta be fussy. Something momentum. No, magnitude just means how big. Something momentum. There's 2 words. What's another word for change in momentum? Okay, this asks me to find the impulse. So, as a habit, what I typically do when they say find the impulse, because I like to write something down to get the mental juices flowing, change in momentum is like that. Delta P with a vector to remind myself, be careful with direction. The problem is I got a whole bunch of ways to find change in momentum. From that 3-in-1 equation, we had m delta v, which I told you was mv final, don't write this down, minus mv initial, and then Brady, there was force times time. Brady, my friend, which one am I going to use, do you think, here? This one with the v final and the v initial in it, or the force and the time? How do you know? Okay. Good. Why did I say magnitude? Because technically impulse is a vector, and I was too lazy to make up directions, so I'm hedging my bets by just saying, how big? Okay. So you're telling me I can do this? On your formula sheet, I wrote F delta T. Time is always a change in, and you're going to notice often I'm lazy. Brady, what's the force in this question? How much time? What's the change in momentum? Thank you for doing that in your head without a calculator. I heard a calculator hit the desk as somebody was reaching for their calculator, and I was going to call them out. Thank you. You did it in your head, yeah? Thank you. 80 what? Well, change in momentum, it is kilogram meters per second, because momentum is kilogram meters per second. But remember I said another way to measure momentum and change momentum was Newton seconds. Since you and I went force times time to find this, I'm going to write Newton seconds. But if you wrote kilogram meters per second, Justin, I'm giving you full marks. But I try and use the context that I was given. Okay. Cool. Louisa, what's B asking me to find? It's impulse. So what is it? You'll notice I didn't give you any room to work for a reason. This one is a Captain Obvious, so easy that it's tough. Pardon me? 80. Newton seconds or kilogram meters per second. Because another word for impulse is change in momentum. Another word for change in momentum is impulse. And it may sound like I'm repeating myself, but having done this before, it's amazing how often on a test I'll say to a student, find the impulse. I don't know. Find the change in momentum. Oh, delta P, no problem. They're the same. They're the same thing. Okay. Thank you, Louisa, for not letting me down. Mandy, what's C asking me to find? What did I find in A and B? Impulse. Have I got an impulse that has a change in velocity in it from my green sheet? Oh, another way to think about impulse is mass times change in velocity. Yes? Hopefully here's where all my plans come to fruition. Could you then, looking at that, Mandy, in your head, rewrite this and give me a new equation for change in velocity that I don't have to add to my formula sheet because I can just rewrite it in my head? How would I get the delta V by itself? Divide what? Yes. Is that okay? Does it say m delta V on your formula sheet? Yeah. Okay. So you're telling me if I want to find the change in velocity, that's the impulse divided by the mass. Mandy, what was the impulse? Yep. What's the mass? You didn't reach for your calculator, did you? You looked at that and you said, I can go 80 divided by 4 in my head. Thank you. 20 what? It's a velocity. Now, it's a change in velocity, but it's a change in velocity. So, now what does this tell me? This tells me that if I started out going 1 meter per second, I finished up going 21 meters per second. That's my change in velocity. Or if I started out going 5 meters per second, what did I finish up at? 25. If I started out going, ready, negative 8 meters per second, backwards, I finished up going positive what meters per second? Forwards. 12. So it doesn't tell me how fast my final and initial are, but it tells me what the change in was. So, D, if the final velocity was 12 meters per second north, what's my initial velocity have to be?
8 meters per second south.
Did the screen just go crazy flicker for you folks there? Nah, I'm a little worried. We probably could have figured out all of these things by using F equals MA, using VF equals VI plus AT, using VF squared equals VI squared plus 2AD, using all that stuff. But all of it would have taken multiple lines, and you'll notice that Brady and Mandy and Louisa were able to do the entire thing in their heads. That's really where the impulse equation shines. It's a nice, lovely shortcut. Let's keep going. Ibrahim, what's A asking me to find an example 2? What's another word, folks, for change in momentum? Begins letter I. Okay, so I could have just said, what's the impulse? Okay, so I'm going to write down change in momentum. I have all these different ways to find change in momentum. Which method am I going to use for this question? Look and see what they gave you. And I'm giving you a little less guidance this time, Ibrahim. Can you figure out which one am I going to use? Yes. In fact, I'm going to go, it's got to be MV final minus MV initial. And I know that for 2 reasons. By the way, look, pause, look up. You can write that down, but I'll show you where it came from. You looked at me a little stunned there, Chantel. On your sheet, it says that. What's change in anything? Final minus initial. So I'm going to say M times change in velocity. That's going to be MV final minus MV initial. Can I do that? Okay. How do I know that? First of all, I noticed they gave me a final initial velocity. And what are they asking me to find in part B? I'm not going to be using force times time in part A then. Yes? Okay. What's the mass? 350. What's V final?
18.
Minus 350. Pause. Is there any change in direction here? Do we have to let one way be positive and one way be negative? Okay, but I would be careful of that. In fact, I think I got you on that last class. Were you the one I got on that last class? It was somebody over this way with the east and the west. Yeah? 350 for M.
Oh, never mind.
Right?
I thought you were.
No. What's V initial? 2.5. Can I do that one in my head? Well, it's going to be the same as 350 times 15.5. Ew, yuck. No, I'm going to wimp out. Use your calculator for this one. Ibrahim, what do you get? 5425? Is that right, folks? Yeah? Units, you could say Newton seconds. I would give you full marks. But since we went mass times velocity, I would probably just, without even thinking about it, write my units as mass times velocity, kilogram meters per second. And I think I did tell you the other day that they're talking about renaming that an Einstein. It hasn't happened yet. Maybe in your lifetime, momentum will be measured in Einsteins. That'd be kind of cool. Gagan, what's B want me to find? What did A want me to find? Another word for which is? I could probably find the force, don't write this down, by going F equals MA, don't write this down. I know the mass. I could then say VF minus VI or equals VI plus AT. I could then say A equals VF minus VI over T. I could plug A into there, and I will get the force. And I will give you full marks if you do that. But, Gagan, is there an equation that has impulse and force in it? Say yes. What is the equation that has delta P, impulse, and force in it? Yep. Don't read me that one. Read me the one that has force. Do you see it? You're on the right equation. It's at 3 and 1. Yeah? Yep. So although I could have done it the way I just mentioned with all those steps, in your head, how would I get the F by itself? More specific, please, people. Divide by what? Yes. In other words, 2 lines instead of a bunch of lines. You're telling me, and you're right, that force is... Remember I told you, by the way, that Newton's second law was F equals ma? I lied. This is what Isaac Newton wrote as his second law. F equals change in momentum over change in time, which is ma in disguise. It has to be because it is a force. But I think I told you the other day, Newton was way more interested in impulse and momentum than just acceleration. But most textbooks call Newton's second law F equals ma because it fits in with forces. What was the impulse? 5, 4, 2, 5. What's the time in this question, Gagan? Yep. What's the average force? 90.4 even? 90.4, like, is it round off or does it go forever? Or is it 90.42 and it stops there? Oh, it repeats. 4-2-2-2-2-2-2-2. 4-1. Okay, there we go. So I just wanted to know where we're rounding off. So we'll go 3 sig figs. I agree with you, Chantal. After all that, 90.4 newtons I would take. What would the direction be? Whatever direction the impulse was. What would that direction be? Well, I'd have to tell you the directions of the velocities. But force gets its direction from the change in momentum. We pause. Have I taught you anything new yet? Hopefully not. Just combining things in ways that we haven't maybe thought of. Next page over. Oh, let's do some rocket science. Cool. Evan, what's example 3 want me to find?
Final velocity of the rocket.
V final. Okay. I see a mass. Yes. I see a force. I see a time. It would be cool if there was an equation that had mass and force and time and V final in it. There is one. I have to do a little thinking to derive it, though. Take a look at the impulse equation. See it? Does it have force and time in it? Let's write that down. Let's write force times time equals Can you also give me the version of the impulse equation that has mass and velocity? Read it to me. Okay, I'm going to write it as mv final minus mv initial. And strangely, what I've just written here, Morgan, is impulse equals impulse, but I've written it in 2 different ways. What does this question say the initial velocity is?
0.
We should have underlined from rest. Remember, we used to do that. Now, you're probably at the stage where you maybe don't have to physically underline it, but at Mackenzie should be a ding, 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 ding. Pay attention here. Little stage now. So you're saying I can do that? What's this question ask me to find?
VF.
How would I get the VF by itself?
Divided by M.
1 line. Again, Evan, you could have gone F equals ma. They did give you the mass. And then you could have said, I'll find A. And then you could have said VF equals VI plus AT. And they did give you a time. And you could have then found VF. But this does it all in one line. It's convenient. So you're telling me that VF is the force times the time divided by the mass? Okay. What's the force? 2.3 times 10 to the fourth. What's the time? 120 seconds. What's the mass? 2.6 times 10 to the fourth. .3 scientific notation 4 times 120 divided by 2.6 scientific notation 4. You get 106.15 106. Okay. Meters per second. Let me again emphasize, and I'm going to repeat myself, but that's okay. You're teenagers, and sometimes repetitiveness is necessary. With teenagers, I find repeating things is important. Sometimes for teenagers, I find I have to repeat things. Sarah did that. You don't have to do it using the impulse equation. All of you, from the stuff we did before Christmas, could have handled this, but it would have been multi-step. About 4 lines or 5 lines. 2. Take that. Hey, Morgan, what's example 4 asking me to find? Force. What did they give me? I see a mass. I see a 32. That's a velocity. I see a 1.6. That's a time. I probably could find acceleration, and I probably could go F equals ma. But let's see if we can use the impulse equation. So the impulse equation that has force and velocity in it looks like this. Force times change in time is mv final minus mv initial. It's mass times change in velocity. First question, Morgan, before I go any further, are any of these 0? V initial is 0? Which one? V initial or V final? Which one's 0? Yes, because it says bring the car to a halt. So V final is 0. Okay. What did you say this question was asking me to find? How do we get force by itself? We'll divide. By what? Yeah. So you're telling me the braking force is negative m v initial over the change in time? Yeah, it is. What's the negative telling me? If the car is traveling north, the force has to be? If the car is traveling, let's be really obvious, forwards, the force has to be? Forwards, the force has to be backwards. Which hopefully is kind of a Captain Obvious. You've been in cars and picked up on that. Okay, so I'm just going to leave the negative in my answer. 1,632 divided by 1.6. I think I do this in my head. Is it 32,000? No? Or 3,200? 32,000, right? Yeah. Negative 32 and 3 zeros. Yes? No? Yeah? Newtons. And again, what's the significance of the negative? In the opposite direction that the car is traveling, which hopefully now makes good sense to you. I like example 5. I like example 5. I like example 5. Example 5, it's a cool question. A rock falls from the top of a 40-meter high building and strikes the ground below. What's the force, magnitude, and direction of the ground acting on the rock if it comes to a stop in 0.350 seconds? Maddie, what's this question asking me to find?
Force.
What did they ask me to find in the previous question?
Force.
In the previous question, did we come to a stop?
Yeah.
In this question, are we coming to a stop?
Yeah.
I'm going to argue these are really similar questions. In fact, I think as a starting point, I can say, well, force times change in time equals mv final minus mv initial. I think, Maddie, I can cross out the mv final. In fact, I'm going to get the same equation that it's going to be negative mv initial over time. Let's do a quick check. Do I know time? 0.350 seconds. Do I know the mass? 2.5. Do I know the initial velocity that we hit the ground with?
Yeah.
What? Oh, never mind. Do I? Sure, no. No. So even though this question's asked me to find the force, you know I'm going to spend most of my time finding, I think, how fast I'm going when I hit the ground. So, draw a little line like that. Any thoughts, folks? Colby. VF equals VI plus AT. Don't write this down. How would that help? So you're telling me that VI is?
0.
What's A?
9.8.
What's time of free fall?
0.35.
That's the time of free fall?
Oh, no.
What? I hooked you. I don't hook you very often. That's the time once you've hit the ground to come to a stop. That's why I said don't write this down. I do agree with you that what we want to find, let's make a little heading here. Let's call it free fall. Hey, what month is it, folks? Hey, we're in the home stretch. This is good review. We did say that when you drop something, VI is 0. What we want to find is VF, and VF, when I hit the ground, is going to be VI once I start stopping, if that sounds okay. A is negative 9.8. That's a terrible A. What haven't I used yet? What else do I know? So what am I going to write? Oh, Maddie. Thank you. Negative 40. Why negative? Because we're ending up below from where we started. Can you give me a equation that has a VI, a VF, an A, and a D in it? She's going to look near the beginning of the year, and suddenly her eyes will light up, and she'll see it. What?
VF squared equals
Yeah.
VI squared plus 280.
Except that's VF squared. So,
What is square root?
and what's VI?
0.
In this case. So really, it's just going to be the square root of 280. Do you see why I like this question? There's, first of all, it's kind of nerdily interesting to me, but also wonderful review going on here. It's going to be the square root of 2, negative 9.8, negative 40, two times negative 9.8 times negative 40 square root. Wow, that's a fluke. 28? Yes? Why must this be wrong? Okay, well, okay, it all depends. We need to decide which way we want to be positive and which way we want to be negative. I think it's easier for us to let up be positive and down be negative. So let's make a little note over here. Up is positive, down is negative. So let's call this negative 28. And let's plug it into our, now we're back to the beginning here, Mackenzie. Maddie, we want to find the force. So it's going to be negative, what's M? 2.5. What's V initial when we hit the ground? Sorry, what's V initial when we start to stop? That's V final when we hit the ground. Maddie, negative 28, yes?
Yep.
Divided by 0.35. I think this might even work out evenly. Or at least nicely. What do you get? 200 even? Do you get that too? Units? Newtons. Direction. Did you get a positive answer or a negative answer? So what direction does the ground apply a force? Which makes sense. It must apply a force up to bring an object to a stop, but okay. It did say magnitude and direction, so I better make sure I give them that. Pause before you turn the page. Did I do anything new there?
Yes.
Just combining stuff cleverly. What more have I got? A couple more? Good. And then a nice little video. I like example 6. I like example 6. I like example 6. Example 6 is a nice question. Ethan, what's example 6 want me to find?
VF.
I could write down VF equals question mark, and then I could run through this and I could see, what's that 4.2? What is that 4.2? I gotta be fussy, it's not the weight. It's gotta be the mass. Weight is mg. Okay, so I gotta get ready? So what's that 4.2? See, as soon as I see that, my brain thinks, wait a minute, maybe I don't want to write down VF equals question mark. Maybe I can find this in one step with the impulse equation, which contains forces and velocities, and forces contain masses. Let's keep reading. I also see a 4.65. What's that? I think it's a VI. Yes? And I see a 350. What's that? A force. And I see a 0.075, a time. I probably could solve this all with pre-Christmas stuff. But let's try the impulse equation. Let's try the version of the impulse equation that has force, time, and final initial velocity in it. What's that one going to look like? So if you look at the impulse equation, Ethan, it looks like this. Force times time equals m v final minus m v initial. It's m delta v, but change it, anything is final minus initial. So what's this question asking me to find?
VF.
How would I get the VF by itself?
And the MVI.
Add the MVI and then divide by the?
M.
Yeah. Did you hear him? Kind of hiding there and a little quiet. So if I hear you correctly, you're telling me VF, the F delta T drops down like a domino. We add the MVI, and you said divide by the M, which is no equation anywhere on our formula sheet, but I think we've kind of derived it ourselves, yes? Okay. Ethan, how big is the force? What's the force? 350? What's the time?
0.075.
Plus, what's M?
4.2.
What's VI?
4.65.
Impossible. Can't be. Why can't it be? Colby.
It's bouncing off the wall.
What direction is the velocity?
West.
No, what direction is the initial velocity, Ethan?
East.
What direction is the force? What direction is the force? Soon as you called that positive, now you're committed. Direction matters. So let's make a little plus sign above the west. Let's put a plus in front of the 350. Let's put a minus sign above the east. Let's put a minus sign right there. We should have done that right away. As soon as you said 350, if there's directions, we have to be careful. Is that okay? So what is V initial? Not 4.65, but negative 4.65. Oh, if I get a positive answer, what direction will that be? West. If I get a negative answer, what direction will that be? East. And divided by 4.2. Is this a fraction? Yeah. Is there more than one thing on the top? Brackets. Is there more than one thing on the bottom? No. I forgot to put brackets. No, I put brackets. I closed it. That was dumb. Plus 4.2 times negative 4.65, all divided by 4.2. Double check my typing. FT plus MV. Oh, wow. Do you get 1.6 even? Positive or negative? Let's be obvious. What did I get? Positive or negative? What does that mean in Ethan's direction system? West. Because it did say in brackets magnitude and direction, did it not? 1.6 meters per second west. So the ball came in, which way is east for you folks? That way. The ball came into the east, it bounced off to the west. Yeah, rebounded. Number 7. I think number 7, I'm going to need way more room. I'm looking at this and going, what was I thinking with my spacing? A little weird, Mr. Duick. Okay. Sheesh. Have to write small. Chantal, what does A want me to find? What's another word for impulse? You know what? I'm going to write down delta P equals, and I don't know where I'll go from there. Now I'm going to read. Folks, what do you think? Am I going to use the final and initial velocity impulse, or I'm going to use the force time impulse? Pardon me? What's my final velocity, Chantal? What's my initial? Oh, okay. I'll go with that. So I'm going to write down mv final minus mv initial, and right underneath here, because I didn't leave you much room, I'm going to plug and chug. What's m? 12 grams. How many kilograms is 12 grams? Okay, so it's not 0.12, it's 0.012. And V final is 250. Oh, Chantal, I guess I could have done that. I could have canceled out MV initial because you said from rest, I think. I don't see any directional changes. Okay. 0.012 times 250. Is it 30? Or 3? 3. I'll go 3.0, and it's impulse, so it's kilogram meters per second, or it's Newton seconds, whichever one you choose to write. Cool. Em, what's B want me to find?
Force.
Emily, what's B want me to find? Force. Very good. Oh, it's amazing how you threw your voice over there. I even saw your lips move. What did I find in part A? I could probably find the force by going F equals ma, and like winner minus like all that. But let's see if we can find it with impulse, because I seem to recall that. Wow, that was strange. I seem to recall that impulse is also force change in time. How would I get the F by itself, my angel? Yeah. So you're telling me that. Yes, you're right. Did they tell me time? Ooh. Well, VI is 0. VF is 250. D is 0.85. Can I figure out T from there? Now, here is where I would make a choice. I could. But could I not also figure out A from there? Using the equation that Maddie dug up a few minutes ago, I think I can pull out VF squared equals VI squared plus 2AD. Because do I know VI? Do I know VF? Do I know D? I think I can skip finding time altogether. And even though I wrote change in momentum over time, I think it's going to be, in this case, faster to go MA, which is still force, because they gave me M. So you can choose, as you're doing these, do a little bit of the math in your head. Which way is faster? Justin, pick that way, unless the question clearly demands that you do it a certain way. So I'm going to go VF squared minus VI squared all over 2D. Remember that one? I'm going to go 250 squared minus 0 squared. I probably didn't need to type the 0 squared. All over 2 times 0.85. And I get an acceleration of, that's really big. Wait a minute. It's a bullet. Should be big. Should be huge. It's a bullet. So I think I'm okay with that. I'll write 3676.5. 3676.5, but I'll keep this on my calculator. And we're totally running out of room. But Emily, what was the mass? 12 grams, which was how many kilograms? Yeah. I'm going to go 0.012 times answer button. I think that's the least amount of work. And since I told you, Aisha, that the impulse equation was meant to be a shortcut, then why don't I pick the shortest way to do it? Do you get 441.17? How about 442? $442 newtons. A couple more, we're done. Consider the diagram at right. So we have case A, a car runs into a wall traveling 5 meters per second and bounces backwards off the wall at 4 meters per second. And case B, a car hits a wall at 5 meters per second, comes to a stop. In which case does the car experience, so now we're going to answer these questions right here. Let's assume the collision time for each collision is the same, and they're identical cars, so the mass is the same. In which case does the car experience the greatest momentum change? Case A, case B, both the same, or can't tell? You know what? Once again, we get a chance to vote. And once again, how high you hold your hand up is how sure you are of the answer. Which situation experiences the biggest momentum change? A, B, C, or D? Who says A? 1, 2, 3. Is that up? 4. Oh, 5. Dom jumps on the bandwagon. 6. Eli. Now 7. Ooh, now 8. 8 going once. 8 going twice. Sold. 8. Who says case B? 1, 2, 3, 4, 5, 6, 7. Ooh. Who says both the same? Emily, were you going to raise your hand? You started to, and you looked around, and then you did this. Are you going? Okay. Who says can't tell? So 15 of you voted. More than 15 of you here. I'm going to start calling you out. Convince me. Yeah. Are you defending an answer or attacking an answer?
Kind of both.
Okay. What did you pick?
I think A.
Convince me.
You said that the time it takes for them to change is like the same.
Yep.
So it's asking about what has the biggest momentum change.
Yep.
I think it's A because it has to go into the wall and then go backwards, while B has to just stop.
Since I said the time was the same, then rather than looking at the impulse equation that has time in it, why don't I look at the impulse equation that has delta V? What's the change in velocity in case B? What's your final? What's your initial? What's final minus initial? -5. What's the change in velocity in case A? What's your final?
Negative.
What's your initial? +5. The change in velocity here is 9 or -9, depending on which way you let be positive or negative. But I'm telling you that first car had a bigger change in velocity, which means it had a bigger impulse. Biggest momentum change, biggest impulse. The impulse encountered by the 800 kilogram car in case A has a magnitude of, how big is the impulse? Well, it's going to be m times the change in velocity, 800. What did we say that the change in velocity was in case A? Not 1, because there's a change in direction. You need to let one way be positive and one way be negative. So you can, if you let the 4 be negative and the 5 be positive, you'll get -9. If you let the 4 be positive and the 5 be negative, you'll get +9 when you go final minus initial. But the change in velocity is 9. Correct answer? E. So, which type of collision is worse for a passenger? Let's assume that the initial velocities and the time of impact are identical. Which type of collision is worse? A head-on collision in which the two cars stick together? Or a head-on collision in which the two cars bounce apart after impact? Eli's not on his phone right now? No? Okay. Once again, we get to vote. Once again, how you hold your hand up is how sure you are of the answer. There's only 2 options, so I fully expect to see everybody voting option 1 or option 2. Who says, Duick, head-on collisions where they come to a stop? That's clearly way worse, Mr. Duick. The first one, 1. The first one, 1. Who says the second one? Why? Because that same thing. Can we use some nouns and less pronouns? It's that same thing, similar to the answer before, that was also, I think, close to being right. That one there. Let's be a little more specific. Colby.
The change in velocity is less.
For which? So, this must be worse. Instead of saying A, the change in velocity is less, can we say for the second one, the change in velocity is? Because you're having to change direction, which means you're having to come to a stop, just like in A, and then get some more momentum in the opposite direction. Well, it's a bigger impulse, a bigger change of momentum. Number 10, and we're done. The diagram below depicts the changes in velocity of a ball that undergoes a collision with the wall. Indicate which case, A or B, has the biggest change in velocity, acceleration, momentum change, and impulse. And let's support each answer. Okay, we got some numbers here. Which one of these has the biggest change in velocity? What's the change in velocity in case A? What's change in anything? So it's going to be final minus initial. What's V final in A? 5? What's v initial in A then? Not 10. Negative 10. So if you let backwards be positive, you can let final be positive. It's really up to you. I don't care. We get a change in velocity of, how big? 15. What's the change in velocity for case B? You're right, Louise said negative 15 if I do it that way. Did I see your lips move and say negative, or were you asking where did the 15 come from? It would be either 5 minus 10, or negative 5 minus 10, depending on which way you let it be positive, which way it be negative. But you'll get a magnitude of 15 no matter what. If you do the same thing here, if you let final be positive, you'll get 28 minus negative 30, which is 58. Which one has the biggest delta V? B. Explanation? Right there. Which one has the biggest acceleration? Explanation? Also right there, because acceleration is change in velocity over time. It does say they both have the same time. If it doesn't say that, it should say that. But one has a bigger change in velocity. Which one has the biggest impulse? Bigger change in velocity, same mass, bigger impulse. Oh, actually that's supposed to be which one has the biggest momentum change, and I've just given the answer for part B because impulse for the last one and momentum change are interchangeable. They're the same thing. Whew. I got a video to show you, but first of all, what's our homework? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1 to 11. That front page is all nice stuff. "12 is good, 13 is good, 14 is good. I'll skip 15 and 16. 17 is good. Let's go water skiing. 18 is a good thought question. 19 is good. 20 is nasty, but you can try it. Oh, I've given you lots of homework, but it's Calvin and Hobbes. Boy, that's a lot I'm throwing at you here. I'll do 22. I'll skip Calvin and Hobbes, and I'll skip 23. Sorry, I'm throwing a lot at you, but we need to practice this.